Thank you very much. Welcome, everyone. My name is István Nagy, and I work for EPAM as a software architect. And I have brought to you my own open source project, Lowkey Vault, which is dealing with Azure Key Vault integration and the testing of the goodness of that integration. So let's dive right in. I would say I have a couple of bullet points to show what we will touch base on today. The first point will be the context to talk about what the issue was I wanted to solve and how important it is, in my opinion. Then I will share some bits about Lowkey Vault itself. Then I have even brought a demo in the presentation, so you will be able to see how well it achieved the goal. And we will have, of course, some time for questions, as I hope. So going to the context, two main points here. What was the issue and why is it important? But before we would go there, I assume that not everyone is super up to date with the Azure Key Vault, as it is kind of a niche product. So I wanted to talk about that as well. So Azure Key Vault, in case you don't know it, is a managed service available for Azure users. It is a secure storage solution for keys, secrets, and certificates. And one of the big benefits is that it supports hardware protection using HSM, and it is an affordable offering while you have access to HSM. So it is a pretty good thing to use this, but of course you might have alternatives as well. So as you know, major cloud providers tend to offer something similar to this, or you can host your own HashiCorp vault or whatever that is solving this issue for you. And the reason why I think this might be relevant to open source projects is that Microsoft started to engage with open source software a couple of years ago, and they are even announcing some program to give service credits for open source projects. It was announced last year, as far as I know. And because of this, it might be tempting to host your open source project on Azure. And since you are there, why wouldn't you use something that might just help you with the security, kind of like a Azure Key Vault? And talking about the issue at hand, let's start with the testing pyramid to put things at a common level. So as you see on the diagram, the testing pyramid has multiple levels. Each level has a name, like unit test, integration test, API test, or UI test. And the size of each layer shows how many tests are there in that particular level. So you can see that the unit tests are the biggest, and then UI tests are the smallest. And as we are getting from top to bottom, the complexity grows. And this comes with some challenges. So we are testing different things on different levels, like unit tests are focusing on the internal logic. Then integration tests tend to focus on the integration with external services or dependencies. API responses are tested on API level, and the end-to-end behavior on the top. And the complexity is coming from using the real services as we are getting to the top or close to the top, while we are allowed or encouraged to use test doubles on the bottom layers to make it more simple, to generate some edge cases or figure out certain issues which are hard to reproduce unless we are using a test double. But there is a good rule of thumb to try push everything to the lower levels as much as possible and have a faster feedback loop and be able to see how your components behave without running tons of tests and setting up a lot of infrastructure just for the sake of testing. So if we shift to the Azure specific part, well, where can we test Azure integration? I would think that it should be somewhere around the API or integration layer, and it is coming from some usual external dependency specific issues. This is not just Azure, so it might be anything that is an external dependency, like a database, whatever it might be. And the main challenges from simply using any dependency are listed on the slide. We need to set up the dependency, we need to clean up after the test execution, and we need to work a lot on isolation between test cases and test runs. Because let's say you have a CI agent and you are running tests from 2 different branches, and you need the same dependency. Those tests will interact and mess up one or the both branches in certain situations. So because of this, it is a benefit if we have completely isolated environment. And to solve this problem, we have kind of 2 options. One is excluding the parts which are problematic, so not testing these external dependencies on the lower levels, but how we will know that they are working. So it is kind of a trade-off. Or we can use something that can start up some test double that is helping us to run these tests in an isolated way. And with this, we will get to Lowkey Vault. Let's talk about 2 issues again, what it is and how does it solve the issue. First of all, Lowkey Vault is basically a test double for Azure Key Vault. It is a fake, according to the terminology. Even the color is not Azure, it is Celtic blue, close but not the same. And this project is using an MIT license, so you can almost do whatever you want with it. It covers the API on the v7.2 level for keys and secrets. So no certificate support at the moment, but the 7.3 version is being prepared. Some basic support is in fact already there, but not the new things. Also, it can be accessed using an executable jar or a Docker container, whichever is better for your needs. And it can use multiple vaults in one container if necessary. The client is compatible with the official Azure clients, so you can use the official integration and really test it. And the only thing that you might need to consider is to use the custom client using the HTTP client provider interface that is built in to the official client. And there is a test containers integration as a third-party module. In case you are familiar with test containers, you will know how great this is. But in case you don't, test containers is basically a Java project, which is helpful for starting up certain Docker containers. It can look after the life cycle, start it when the test starts, and shut it down when the test finishes. There are some hooks even with the test frameworks. So it is a wonderful thing. I wish I knew it earlier. So I can encourage you to go there and see what it is. But back to Lowkey Vault, it provides a management API as well to allow dynamic vault create and delete or change operations. This will be very helpful to lower the number of containers you need if in case you have multiple vaults in your system and you want to test all of them. Talking a very short slide about the Vault client itself, this is something completely optional. So in case you don't want to use any of the benefits listed on the slide, you can just disregard it and go with the official client. But in case you decide to use the Lowkey Vault client, you will have a Java client that is convenient to access the Lowkey Vault management API. Also, it will solve some routing issues, which is mainly problematic in case you are using multiple vaults in one container. The reason for this is that Azure Key Vault, or the way Azure Key Vault and the official clients work, is assuming that each vault has a custom domain. And because of this, just starting up a container on localhost and 8443, you won't have this opportunity unless you are defining some hosts or figuring out some way to route things there. But the client is taking care of a proxy layer, so you can use logical domain names, and it will translate to the physical domain name and port number that is being used by the vault. This is particularly useful in case you are using the test containers integration, because it is capable of starting up on a random port. And in case you wish to, let's say, restore a backup from a previous state, those backups will have the logical names in them. So the port number would not match, but this way you are free to use the logical name from your application. And also this client ignores the certificate issues that are caused by the self-signed nature of the vault certificate. And it adds some convenient things like automatically adds the authentication headers, and it says the API version as well. Then the next thing, how can we see that this will solve the issue? Well, I imagine that you would have a test code in this situation. Also, you would have a system under test, and that needs to be tested. And this system has some dependencies. I've separated two kinds of dependencies. So one is the Lowkey Vault or the Azure Key Vault dependency. The other is everything else, just for simplicity's sake. But there is a common pattern. So the test code starts up the dependencies, then it will tear down them in the end of the test. The testing will be done by the test code, obviously, and the system under test will use both kinds of dependencies. So with that, we know the theory. I would say let's put it to the test. Start with starting up the Lowkey Vault jar in this case. The slide says 1.2, but we are in 1.4.0. I believe it was a busy week, so a lot of things happened. You will see something like this if you manage to start it up with this convenient command. Talking about the example app that we will use for this, it is a Spring Boot application with a very simple entry point, just starting up the context. The two main things I would call out are the interfaces for the Azure Key repository and the Azure secret repository. The key repository gives us two methods. One is decrypting things, the other is encrypting things. Of course, using the the key inside the key vault. And in case of the secret repository, we are simulating the situation that we need to fetch like database connection information. So the connection URL, then the username, then the password, and these are the three methods what we use. Talking about the implementation itself, the key implementation, as you can see on the slide, is getting a key name in one of the fields. It is injected there. Then we have a client, and we have a function that we convert that key into the cryptographic client for the operation. And the two implementations are very simple. These are just the pure official code, basically from the official client. We are just getting a key, and then we are turning it into a cryptographic client, then using decrypt or encrypt with an RSA algorithm. And going forward to the secret repository, it will be similarly simple. We have three parameters in this case: the username, the password, and the URL. These are the names of the secret. Then we have a secret client, and basically the secret client is just used to get secret based on the name, then get the value and return it. So it's very simple. Talking about the config, we will need obviously a vault URL where our vault lives. We will need some token credentials and some HTTP client to access it. The two clients are created in the bottom section. Those are very simple, and we are just passing through everything what we get. So the URL, the HTTP client, the service version, and the token credentials. This is again coming from the official client, so nothing interesting to see here. Talking about the cryptographic client, it is similarly simple, but in this case we have an input parameter which is the JSON web key. This is necessary because in the crypto client, we need to figure out what is the key it needs to use. So as you can see on the code, the key .get ID will return this URL that will be used by the client, and this way it will figure it out where the encryption and decryption should happen over HTTP. Talking about the Azure credentials, the missing link, we will have two things, a username and a password. It is not necessarily used by Lowkey Vault, it just fakes it, but in the real integration, you would need some way to authenticate. The real thing supports multiple authentication options. This is just one of them. And it will generate a token credential for you, and it will generate the official HTTP client. So this is not the own client I have mentioned. This is the Microsoft one. And regarding the test code itself, we need to set up our tests. It has a couple of annotations. So on the top, we can choose between 3 different configuration options. These are using Spring profiles. So we are either telling the test to start up everything from a jar file, or we are telling it to start up from Docker using test containers, or we are telling it that we will take care of starting it. Since we already started, this will be the one, so the external start config. And it will put together the context, it will override the URL for the vault, give the 2 things that need to be tested and a couple of input parameters just for the test setup. The first method for the test is very simple as well. We are basically generating through 3 plausible values for an admin username, a password, and the URL that will be needed for database connection. We are just using the secret client to set up these inside the vault. Then we are using the secret repository to fetch them one by one. And once we are done, we are comparing the pairs. So we are comparing the input username with the fetched username and so on. And we would like it to match, and it will. Regarding the other test, the keys, we have in this case a secret that will be a secret message, and this will be encrypted and decrypted, and then we will compare the decrypted version with the original. We are generating a new RSA key with the key client. It will have the key name that is coming as a parameter. Then we are setting up a couple of operations to support encryption and decryption. Then we are setting the key size, which is 2K in this case. And in the when section, we are using the key repository to encrypt and decrypt one after the other, and we are saving the values. Then we are comparing the secret with the decrypted value, and we are even making sure that the encrypted version and the decrypted version is not the same length when we are converting it to a byte array. This will help us to guarantee that there is no magic or some dirty trick in the background, just storing everything in plain text and returning when we are calling decrypt. And in fact, Lowkey Vault will do the encryption. If we run these tests, we would see an output similar to this. It would see that everything passed and the build was successful. Then switching over to the Lowkey Vault logs, this is the interesting bit. We would see that we had 3 calls creating secrets, one after the other, with user, password, and URL. Then we are getting those secrets in the same order. If you remember the test code, this is exactly what we told that it would do. Then the second test case is creating a key named RSA key. Then it will get that key and then get the specific version of that key. Then it will encrypt using that key. This is done implicitly by the encrypt implementation. Then we are getting the key again, the latest version, then the specific version, and then we are calling decrypt. This is again implicitly happening in the background. And this was the demo part what I wanted to show. I have collected a couple of references, the Lowkey Vault project home, the link to this example project what I have shown in case you wanted to get your hands dirty and try it out for yourself. Then there is a link to the test pyramid from Martin Fowler, a product page for the Azure Key Vault, then the announcement to the Azure credits for open source projects, and test containers, of course, because it's a great project. My name was István Zoltán Nagy, and I have put my my contact info on the right-hand side of the slide. In case you have any further questions after the presentation, please let me know. I will try to answer. And thank you for your attention.
Thank you, István, for this nice presentation. And we don't have any remote questions, but I would like to ask the local. But I would like to ask the local visitors that if they have any question or not. No? In this case, thank you. Thank you again for your presentation, and see you.
Thank you very much. It was my pleasure. Bye.